Hello, my name is Tori DeSalvo, and my presentation is on the effects of prescribed burning on plant community richness, diversity, and evenness, and soil pH and organic matter content. Let's begin by defining prescribed burning. According to the Indiana Division of Fish and Wildlife, prescribed burning is the, quote, thoughtful and skillful application of fire to a specific site under selected weather conditions, and is one of the most cost-effective methods for managing plant communities and controlling natural succession, end quote. It is commonly used to reduce incursions from woody growth in grasslands, control the spread of invasive and foreign species, and remove layers of litter and accumulated organic matter that can hinder wildlife mobility or suppress the growth of propitious vegetation. It can also incite the germination of helpful plants like wildflowers by breaking down the seed coat in a process called scarcification, diminish the buildup of dangerous fuel loads which could cause highly destructive wildfires in the future, and boost pasture fecundity by releasing nutrients bound to decaying organic material. Prescribed burning has been used to restore the native and wild plant species dominance in a plethora of ecosystems, and is a technique the Cincinnati Nature Center has been using for decades. Located in Milford, Ohio, the Cincinnati Nature Center, or CNC, is a nonprofit nature education organization. According to their website, the CNC is among the top 10 nature centers in the country, and one of their missions is to, quote, strive to maintain healthy ecosystems by enhancing, restoring, and preserving native biodiversity, end quote. In 2012, the Nature Center began transforming abandoned fields into native grasslands by uprooting non-native and invasive species and replacing them with native grasses and forbs, and using prescribed burning, which is performed by an Ohio-certified prescribed burn manager during the spring months. Their website states that if prescribed burning is not used, trees, shrubs, and invasive species will move into the prairies and crowd out native wildflowers and grasses, and that utilizing fire is, quote, the most ecologically appropriate and cost-effective management technique to improve the quality of the habitat and control such invaders, end quote. However, there seems to be no data available on their website, including whether the Nature Center has seen significant improvements since the implementation of prescribed burning. This study aims to find a correlation between plant community species richness, evenness, and diversity, soil quality and pH, and this widely used conservation practice. The null hypothesis in this experiment is that the plots that have experienced burning will not differ in plant community richness, diversity, and evenness from the plots that have not experienced burning, while the alternative hypothesis is that the plots that have experienced burning will differ in plant community richness, diversity, and evenness from the plots that have not experienced burning. Now let's take a look at the materials and methods used to conduct this study. Data was collected using plot quadrant community and population abundance estimate technique, as well as by observing plant species present in 3 separate unburned locations and 3 separate burned sites. The plots were picked using a map provided by the Cincinnati Nature Center that highlighted the burned locations and the trails neighboring them. Here, they are marked by the dark red circles. The fields visited and their specific locations are represented by the red star, the burned plots, and magenta rhombus, the unburned plots. Once the fields were located, a 10-meter-long transect was placed along its side. Then, a random number generator with numbers 1 through 10 was used to select the specific site to eliminate any bias. If the number generated was 2, then the quadrant was placed near the 2-meter mark. Due to the height of the plants, which were 1 meter tall in many cases, I was unable to go deep into the field and had to resort to observing the plants that were closer to the edge of the field. Once the plots, burned and unburned, were determined, a 1 by 1 meter polyvinyl chloride pipe quadrant was placed on the area, and the plant species within it were counted as individuals and identified to analyze the factors listed previously. Photographs of the individual species in each plot and an aerial view of the plot were also taken to keep record of the types of plants present and to estimate the percent cover. This was done by overlaying a 5 by 5 grid over the plots so that there were 25 squares, as is seen on the image to the right. The amount of coverage of each species in each square was estimated, then multiplied by 4 to get a percent out of of 100. When a plot contained fungus, it was not counted, as fungi are not plants, and therefore are not indicative of plant diversity. When a plot contained moss, it was counted by the individual sprouts or stems, as is seen on the image to the left. Not all of the stems were circled to avoid cluttering the image, but each one was counted as an individual. Identification was primarily done using the Ohio Trees and Wildflowers Guide by Pocket Naturalist. The second source for identification was the Ohio Wildflowers app, with a database of over 8,000 plant species. The soil organic matter content was examined using soil texture and particle size observations and a simple swabbing technique, which consisted of spreading approximately 5 grams of soil from each quadrant on a clean sheet of printer paper to see the color and nutrient richness. The soil was grouped into one of 4 categories based on the elements of ecology textbooks, soil, texture, and particle size information chart. Feel free to pause the video here to take a closer look at the categories. The pH of the soil was measured using a K-Kernowho 3-in-1 soil, moisture, light pH test kit probe. Data was collected using a simple notebook and pencil 3 times on 3 separate dates within the first 3 weeks of the month of November 2021 to prevent the cold from killing or suppressing the growth of plants and affecting the final results. Once the data was collected and organized, the Simpson's diversity indices, Shannon's diversity indices, and Shannon's equitability indices were calculated for each of the 6 plots to analyze the species diversity and evenness. A t-test was then performed using the following equation to conclude whether prescribed burning really affects the plant community's diversity and evenness. The richness was simply calculated by counting the total number of species present in each plot. Now let's take a look at the results. This table shows the Simpson's diversity index, or SDI, the Shannon's diversity index, or H, the Shannon's equitability index, or E sub H, the richness, the total number of individuals, and the average population size for all 6 of the plots. Due to the nature of this experiment, an unpaired t-test was run with the significance level at 0.05 and 4 degrees of freedom. The calculated p-values for the Simpson's diversity indices, Shannon's diversity indices, species richness, and species evenness are shown on the screen. This graph reveals an unexpected trend. The Simpson's diversity index for the burnt plots is actually lower than that of the unburned plots on both days 1 and 2. On day 3, the diversity indices are identical. The black lines on each of these graphs represent the standard deviation. This next graph compares the Shannon's indices of all 6 plots on days 1 through 3. For days 1 and 2, the Shannon's index of diversity was higher for the unburned plots rather than the burned plots. On day 3, however, the diversity index of the burned plot, plot 5, was higher than that of the unburned plot, plot 6. Finally, this graph shows the species richness of each plot and how many of those species are weeds, non-native, or invasive species. As for the soil pH and textural group, the unburned plots had a mean pH of 7.5, while the burned plots had a mean pH of 7.6. Both of these values are in the recommended range for soil pH of grasslands according to the United States Department of Agriculture. There were noticeable differences in the soil texture and organic matter content between the burned and unburned plots. It was observed that the plots that had been burned were far richer in nutrients due to their soil's dark color and easy ribboning. This table shows the pH, light, soil temperature in degrees Celsius, moisture, and texture of all 6 of the plots. So what do all of these numbers mean? The calculated p-values, by conventional criteria, are considered to be not statistically significant. Therefore, the null hypothesis is accepted, and the prescribed burning of fields does not increase the plant species diversity, evenness, or richness. These findings were quite unexpected due to the abundance of research and studies conducted on the topic mentioning the outstandingly positive effects prescribed burning has on plant and animal biodiversity. Although the statistics calculated indicate that prescribed burning is of hardly any use, there are many other factors that field owners should consider that aren't immediately visible when looking at these charts and graphs. Firstly, the types of plants that were present in each plot. In this study, it was found that the plots that had been burned had fewer weeds on average. The unburned plots on average had 15.33% estimated cover as weeds versus the 1.33% of the burned plots, a difference of 14% on average. However, the unburned plots had an average of 8.33% estimated cover as dead leaves versus the 8.67% on the burned plots. Research suggests that faster rates of decomposition are present in healthier soils, and thus there should be less decaying plant matter on the surface. The cause of the this percent difference is unknown, but it can be assumed that it is due to the cold weather conditions of mid-November. This is something that the diversity indices do not take into account. The richness of the plots is also to consider. While the unburned plots had on average 7.67 species total compared to the 6.33 of the burned plots, the unburned plots on average had 2.33 weed species compared to the only 0.67 of the burned plots. This indicates that although the unburned plots had more species richness, the burned plots had more native species and are therefore healthier according to the goal of the Cincinnati Nature Center. Another important factor to note is that the results of prescribed burning are not instantaneous. According to the private land partnerships, the success of a burn can be determined after a year has passed. Because the fields used in this study were burned roughly 7 months before data collection, the effects of prescribed burning may not be on full display. It is important to note when reviewing the results that this study was incredibly limited, with only 6 samples recorded. If this study were to be conducted again, at least 16 samples should be collected by professionals well-versed in plant identification in order to ensure that the data is correct and objective. Furthermore, many aspects of the process were susceptible to bias. While the sample locations were chosen randomly, the counting of the species may have been skewed, and the plants misidentified due to my lack of knowledge in the field of botany and wildlife identification techniques. This may have caused the diversity indices to be incorrect. I am also not well versed in which species are native and which are not. I used the resources I had, such as the Ohio Trees and Wildflowers Guide by Pocket Naturalist and the Ohio Wildflowers app to my advantage, but the probability that I have identified a plant as a weed while in reality it was a native plant, or vice versa, is likely quite high. Also, as mentioned in the materials and methods, I was not able to sample locations deep into the field due to the height of the plants, which limited the quality of data that could be collected. This problem could be worked around by using professional equipment to get through the tall plants, without harming them in the process. While prescribed burning may not have resulted in major differences between the burned and unburned plots, Simpson's and Shannon's diversity indices, the soil quality and lack of non-native and invasive species all indicate that the burned plots were healthier. Simply looking at the images of the burned versus the unburned plots is a qualitative way to further support this point. As you can see, the unburned photos on the left have a lot more woody growth and weeds compared to the burned plots to the right. For this reason, I believe that the Cincinnati Nature Center should continue to utilize prescribed burning to control the invasion of non-native species and preserve the diversity and health of their fields, and that other landowners should implement the same techniques under the control and supervision of professionals. Thank you for watching and have a wonderful rest of your day.